Welcome to our video on teaching with the DataSnap Impact STEM Lab. Today we're going to talk just about our Impact STEM Lab, right? We have other videos to talk about projectile and air racer. Our goals today are to tackle these 5 things, right? Because we want every single teacher to be successful in the classroom. So we're going to look at what is provided, what is needed, how do you set up a classroom, how do you manage student-driven learning with teams, and what does it look like to collect data with the motion sensors? Let's dive in. First off, you are provided with, of course, DataSnap motion sensors, impact ships, exosuits, and always free access to the DataSnap app. Now, to best use these things, you're going to need some additional items. One, for each team, you're going to need a Bluetooth-enabled device that has Wi-Fi that allows us to access the web browser app or the apps that you can download from the Google Play Store or the Apple Store. All right. Chromebooks, phones, tablets, laptops, computers all work great. Chromebooks are my favorite. It's also a good idea to have rulers and scissors for your groups. Because we are really working hard to engage students in authentic engineering experiences, we're also going to need some access to consumables that let students be creative as they develop their solutions. Here's a list of many different consumables. You can see in the picture from one of our pilots, this teacher did a phenomenal job of just looking around her room, all the things that were hiding in those storage cabinets, in her neighboring teacher's storage cabinets, and she just created a collection of options for students and their teams to build from. Now, I will say, we've seen some of the best solutions from classrooms that provided just a few, even just one consumable. One of my favorite examples was a classroom that only provided paper, because that really made the students and teams think about what are all the different ways I can fold, cut, roll, and attach paper to achieve the solution I want in the lesson. What does it look like to set up your classroom? Here's some of the things you want to think about. One, where are you going to place all your consumables so it's easy for team students to access? Two, teams need a place to work. Now, a lot of classrooms are moving away from rows of desks to creating pods or groups. That's a perfect place for students to engage. Three, we suggest setting up a sensor station. That's a place where you can keep your wireless charging cases plugged in, and that just allows students an easy place to know this is where sensors always come and go. By having that sensor station, right, you're going to create a place where when students and their builds are ready, they can come over to, they can pair their device with their sensor, mount it in, and now they're ready to go. That means they should then move over to a test zone. Now, sometimes you're going to be doing tests where you're just dropping the sensor. Sometimes you're going to be doing tests that are a little bit more involved where you're using a built engineered impact ship, right? So what that test zone looks like depends on the lesson. And then because we are always being realistic, we got to think about storage. We know that a great in-depth, powerful experience probably isn't going to last just one class period. So where are you going to store these so that you can use them the next day and the next day? We did make these purposely nestable, so when you're not using them, right, from this year to the next, it's really easy for them to collapse down and be easy to tuck away wherever. Next, what does it look like to manage student-driven learning with those teams? Now, we've created a curriculum that really helps set the teacher up for success. Right? And what success looks like to us is the teacher is freed from the front of the room and can wander and help groups as needed, serving more as a facilitator instead of a content deliverer. Now, to make that happen, we've got 2 things in play. First off, to hold individual students accountable, all of these products, DataSnap products, come with an engineering workbook for students. That's editable, so you can customize it to fit your needs, but it truly is ready to upload into your LMS, Google Classroom, Schoology, Blackboard, whatever, so that as students are working through the curriculum, they, as an individual, are collecting the information, doing sort of participating in that learning experience as an individual, and then also as a place to record the data that they're getting from the sensor. Now, guiding the whole process are the student-facing slideshows, one for each lesson. So each team of 1 to 5 students, I like to say ideally 2 to 4, right, is following along. Let's say they're doing lesson 1, right, is following along with their slides. Maybe you have one student or who has their Chromebook out, and they're the ones who are in charge of like showing the lessons, while individuals are working on their student engineering workbook. But now that's our instructional model. So now the teacher is not standing in front of the room delivering. The teacher can move from team to team, helping to keep them on task and making forward progress. Now, what does it actually look like? What is the flow of learning with DataSnap? Right? So this diagram kind of captures it. Because we're trying to engage in authentic engineering, that means we need iteration, rapid iteration to occur. So what it looks like is teams are following the curriculum. They're doing their builds for their challenges or their explorations. Once they're ready, they're going to come over to the pairing station. They're going to put their sensor into their device, right? They're going to get it paired with their Chromebook or their tablet or their laptop. Then they're going to go collect their data in the test zone. Once they get that data, right, they take the sensor out, put it back, they head back to their table, and they re-engage with that lesson to drive that rapid iteration. So they're constantly using their learning, using the data to grow and engineer the things that they're creating. All right, now let's dive into what it looks like to actually collect data. I'm going to switch the screen up in a second, and what I want you to pay attention to are these things. One, how simple the app navigation is. We made this truly student-facing. Two, how easy it is to pair my device to the sensor. Three, what it takes to conduct a successful test, right? Then what it looks like in the app to get lesson relevant data, how that app sets us up to build graph interpretation skills for our students. And then I want you to think about how this whole experience truly lets students experience this idea, this real world idea of rapid iteration. So let me switch my screen up real quick here. Give me 1 second. All right, let me return. Oops, okay, let me return back to home. All right, so we are in impact, right? So you see a little egg. And today we've got 2 levels of curriculum in each of our DataSnap motion sensor curriculums. So we're going to go advanced. And let's say today we're in lesson 8. So we're going to choose lesson 8. And so now, as a student, I've got my device that I've built. So I'm going to come over to the sensor station. I'm going to grab a sensor. And as soon as the sensor leaves the docking station, that's where it's charging, which to be honest, it doesn't need to be charging. These batteries will last all day. It now enters into a pairing mode. So now I can, where'd my cursor go? Here it is. Pair. And I want you to watch what happens to the color, right? So we have this really amazing color coding system. So what students see in the app matches the colors and the pattern of flashing that's happening. And you'll notice the color in the upper corner of my app matches the color of my sensor. That helps teams confirm that they have paired with the correct sensor. But we've also did, if I click flash my sensor, right, now I have a very visual, obvious, yes, I am connected to the right sensor. Now that it's paired, it's ready to collect as soon as I hit start recording, but I'm going to mount it in. So I just built up a really simple impact chip, nothing fancy, some pipe cleaners, a paper towel, toilet paper roll, some paper towels. I'm going to put it in my exosuit, kind of just like an astronaut gets into their spaceship seat and gets buckled in. Then I'm going to put the other half on. Oh, where'd my rubber bands go? Here they are. The other half onto my impact chip. And we created this really easy system for connecting the 2 halves. We wanted to make it easy, right? So it's just rubber bands that hook around. Right? And you can use 6. I'm going to just use 3 for speed today. Right? And the reason we created this, just as I'm getting this set up here, is what we saw during the egg drop right, was that students really struggle with building, right? If they just start with an egg, let's say, or they start with just a sensor, how do I build on this? How do I actually make something off of this? So by creating the impact ship and the exosuit, we created a platform that's really easy for students to add consumables to, whether it's pipe cleaners, string, yarn, tape, zip ties. I mean, there's just so many different things you can do with this. And then with the top and bottom, what I love seeing teachers do is they'll take a team, they'll divide it in half and say, okay, you two, let's say you have a team of 4, you two, right? You guys are designing the top half. You two are designing the bottom half. Now, what's interesting is the lessons have prepared them. They now have, because we're in lesson 8 for practice right now, they have a bunch of strategies by the time they get to lesson 8 to think about how to design an impact ship that won't let my egg break here. All right, so I've got it mounted. I'm ready to go. I'm going to, oh, where did my cursor go? I lost it. Here we are. All right, I'm going to click start recording. And I know you probably can't see it. And when I hit start recording, it's going to begin flashing. That's my visual clue. So start recording, drop it, let it come to a rest, hit stop recording. Now, what's going to happen is this sensor has collected thousands of data points, right? And it's got a bunch of different sensors all in there. Right? And we've got some really powerful algorithms that are now going to take all of that data and they're going to say, right, what is the most important information that the student needs in lesson 8? And it's going to clean that data up and it's going to present just the valuable data points that the student needs, in this case, for lesson 8. You can see it right on the top. We're on lesson 8. Okay. Now, where students' eyes first go to, of course, is that egg survival icon. And I mean, you and I probably know this was not a very well designed egg ship, impact ship. So the egg broke. But what's most fascinating, I watched this in all of our pilots, is now students start to build a sense of what these numbers mean, right? Having taught physics and engineering before, right? Newtons, meters per second, G's, what do those mean, right? If it's just a word problem, it means nothing to in the real world to students. But now students start to see, as they change their design up, they see these numbers begin to shift, which is right now we're building a real world context for these ideas of impact G's, force, velocity, acceleration, height, so on and so forth. But what's also amazing is that algorithm, right, has taken that data and has created a matching graph, right? So it's taking that actual drop and it's presenting, right, acceleration over time, velocity over time, distance over time, right? And if you've been teaching for a while, you know teaching graph interpretation is incredibly hard. I can even zoom in, right, on these data points if I really want to get in there to see what's going on. And now students have their data, they've recorded it in their engineering workbook, right? They're actually going to do multiple trials, right? Because that's good science, right? For the teacher who wants, you do have the ability to download that data into a CSV file, right? And then have students do additional things that might better fit your curriculum. Let me switch real quick here back. So now, right, students are ready. They're going to come back to the pairing station. They're going to remove the sensor, put it back for the next group, and then they're going to head back to their table and continue with the curriculum and that learning experience. Now they've got a set of data, right? And what the curriculum does is it says, okay, with that data, what have you learned? Right? Now, let's try something better. Let's iterate, let's evolve that design, because that's what engineers do. They don't stop at version 1, right? They keep working to make it better. Right? That right there captures pretty well what it looks like to teach, right, in a snapshot with the Impact STEM Lab and the DataSnap sensor. If you have any questions, please feel free to reach out. We are always excited to work with teachers, educators, administrators to help think about and imagine what it takes to implement DataSnap into your classroom.